So hello friends. Hello friends. So today we will discuss the polar plot of this system, which is given by gs is equal to 1 by 1 plus s, right? So the very first step is, first you put s is equal to j omega. You convert this function gs, open loop transfer function gs by 1 plus s, into frequency domain, right? Once you convert this into frequency domain, then you have to put this s is equal to j omega, right? Put s is equal to j omega, so it will become g of j omega 1 by 1 plus j omega, right? Now calculate the magnitude. Magnitude is 1 by under root 1 plus omega square, right? See, if there is a complex number a plus jb, its magnitude is under root a square plus b square. And if you want to calculate the angle, then you have to write tan inverse b by a. So this is in the form of a plus jb. A is the real part, that is 1. B is imaginary part, that is omega, frequency in radian per second. Omega is in radian per second, it's a frequency. So calculate magnitude. When you calculate this, it will become 1 by under root a square plus b square, that means under root 1 plus omega square. And when you calculate phase will be 1 by tan inverse b by a, that means omega by 1. Tan inverse imaginary by real, that means tan inverse omega by 1, omega by 1, right? So that means here you will write 1 by tan inverse omega by 1, or when you take into numerator, it will become minus of tan inverse omega, right? Minus tan inverse omega. Now simply you make a table in which you have to calculate phase angle at different values of this omega, starting from 0, 1, 2, 3, 4, 5, 10, 50 till infinity, and calculate magnitude at these value of frequency, right? So this is my phase g of j omega, angle g omega in degrees, and this is my magnitude, right? So when you put omega is equal to 0 here, you will get phase will be 0. And when you put omega is equal to 1 here, you will get magnitude. When you put omega is equal to 1 here, you will get magnitude 1, right? So likewise, put omega is equal to 1, 2, 5, 10 till infinity, and calculate phases and calculate magnitudes like this. So at infinity, your phase become minus 90 and your magnitude becomes 0, right? So now you want to plot this, right? So when you want to plot this, it will become, see, you will start from here, right? So angle clockwise, it is negative, so this is 0, this is minus 90, this is 180, this is minus 270, right? So again this becomes 360. One circle is 360. So 0, minus 90, minus 180, minus 270, and 360 minus, right? So 360 is 0 only, right? So now at omega is equal to 0, magnitude your magnitude is 1 and phase is 0. So put omega is equal to 0. At omega is equal to 0, you get magnitude 1, that is constant. It is plus 1, so that means it starts from here, right hand side, and its angle is 0. So that means you will get this particular point. Now when you see omega is equal to 1, you will see that your angle is minus 45 and magnitude is reducing from 1 to 0.7. That means somewhere around this you will get the next point. This is the next point. It is omega at omega is equal to, this is at omega is equal to 1, right? Magnitude is, if you observe, it is reducing from 1 to 0.7, then 0.4, then 0.19, then 0.09, like this, and finally at omega infinity magnitude becomes 0. And phase, if you observe, it is omega at omega is equal to 0, it is 0, and then it is increasing in the negative. That means 0, then minus 45, minus 63, minus 78, minus 84, and likewise at infinity, omega is equal to infinity, it is minus 90. So this is at omega is equal to 1. Next point, now omega is equal to 2, your phase is increasing in the negative side. Suppose this is minus 63, and your magnitude is reducing to 0.44. Further at omega is equal to 5, if you see, your magnitude is further, if you see at omega is equal to 5, magnitude is further reducing 0.19. That means somewhere around it will come magnitude, right? Magnitude will be 0.19, it will reduce, right? And now your angle is minus 70, that means this is the phase, this one. So this is the next point. Similarly, at omega is equal to 10, your phase angle is minus 84, it is phase angle is increasing in the negative side, that means this is the phase angle minus 78, right? This is the phase angle, this, right? So from here to here, this is minus 78 and magnitude is 0.09, that means somewhere around here. So this is the next point. So likewise, at omega is equal to infinity, if you observe, this becomes, magnitude becomes 0 and phase angle become minus 90. So that means your plot will terminate like this. So plot will start from here. If you join all these points, if you join all these points, that means you will get this kind of curve. So this is called my polar curve, right? Polar. This is polar plot, right? So starting from omega is equal to 0 at constant value, right? At a constant value it is starting and it is terminating at omega is equal to minus 90 degree angle with 0 magnitude, right? So this is, my dear friend, this is the polar plot of this given system GS by 1 plus S, right? So this is the polar plot. Now if you want to plot the Nyquist, then you have to do the contour mapping, right? And so you understand that this is the polar plot, right? So this is the imaginary axis, this is the real axis, right? So likewise, calculate phase and magnitude and you can plot this polar plot, right? Thank you very much. Thanks for watching.